you have a fraction that has multiple terms in the denominator, and really for this section we'll restrict it just to 2 terms. Right? But if you have, in this particular case, you have 2 terms, at least one of the terms has a radical in it, you need to rationalize it, because again the simplified radical has no, or there's, to simplify an expression, there's no radical in the denominator. Okay, so there's 3 steps for this. I'll illustrate the steps as we go through this example, and then I'll give you again a couple problems to try on your own. The very first step, just like with all the other, any problem that involves a radical, is to simplify the radical completely. Right, so you want to take all the radicals in your expression and reduce them if you can, remove any perfect square factors if you can, just simplify what you have. So in this particular case, are there any radicals we can simplify? No, root 7 is as simplified as it gets. Okay, so we move to the second step, which is the rationalizing step. Okay, and this involves a concept that's probably new to you unless you guys dealt with imaginary numbers last year. Did anybody ever do the square root of -1 or i's? Okay, so if you dealt with imaginary numbers, you may have seen this term before. But what you're going to do to rationalize this is you're going to multiply the numerator and denominator by the conjugate of the denominator. Okay, so what is meant by conjugate? Okay, so when you're dealing with these radicals, the conjugate is simply a form that takes, let's say we have a radical, a plus b root m. The conjugate's going to be the exact same terms, opposite sign between them. Now understand that you're not just taking the opposites of each term. Okay, you're going to take the 2 terms. So if I wanted to find the conjugate of this expression, I'm going to take my 2 terms a and b root m, and all I'm going to do is I'm going to change the sign between them. So instead of a plus between them, it's going to be a minus. Okay, so I can also illustrate that in the following way. If I took root c minus root d, and I wanted you to find the conjugate of that, it's going to be the same 2 terms, root c and root d, except you change the sign between them. So what would the new sign be? Plus. And again, this works in both directions. Okay, so it can go either way. You can find the conjugates. And the whole idea behind finding a conjugate is based on this expansion pattern for for polynomials. If you took the sum and difference of 2 terms, so a plus b times a minus b, okay, and then you FOILed this, you expanded it out, okay, you would get your first terms have a product of a squared. Your outer terms have a product of negative AB. Your inner products are positive AB. So what's going to happen right there? They cancel out completely. And then your last terms, B times a negative B, is negative B squared. So do you remember this expansion pattern, product rule? When you multiply the sum and difference of terms, it's equal to the difference of the squares of those terms. Okay, we'll talk more about this in the next chapters. Okay, but this is something that should be familiar to you. You can expand it out, unfoil it to derive it. But this is the basis of choosing a conjugate when you multiply these. Because what's going to happen when you multiply 2 terms and one or both of them contain radicals is if you square the terms, you're going to get rid of that square root. And then the outer and inner terms cancel out completely. So you're going to eliminate all radicals from your denominator. Okay, so that's why you choose the conjugate. So when we actually do that step 2 in this problem, we're going to take just our expression in the denominator. 3 and root 7 are the terms. And we're going to use what sign between them? Subtraction, because it's the opposite sign. And now when we multiply across, we complete the last step, which is you're going to completely simplify the resulting expression. Okay, so when we go through this last step here, just leave your numerator as factors. There's no reason to expand it out or distribute it. Just leave it as factors, 2 times 3 minus root 7. Right, and then in the denominator, you apply this rule? Well, the rule is the sum and difference of terms when you multiply them is equal to the difference of their squares. So we square the first term, what's 3 squared? Always a minus, and we square the second term, what's root 7 squared? 7. And so now it's just a matter of simplifying this completely. Leave it as factors, 2 times 3 minus root 7, all divided by what's 9 minus 7? 2. Cancel your common factors. And again, that's why in that first step, when you multiply across the top, there's no reason to distribute your 2, because it may be the case that you have to cancel factors anyway, and it's simplest to just leave it as factors in order to do that. And so your answer winds up being 3 minus root 7. All right, I want you to try this problem on your own. See if you can simplify this expression by rationalizing the denominator. Negative 5 over 2 plus root x. All right, if we take a look at this, step 1, can we reduce the radicals at all? No, root x is as simplified as it gets. So let's multiply by the conjugate of the denominator. So we're going to take the same terms, 2 and root x, 2 and root x, and we're going to change the sign, so we use the subtraction. And when we do that, we multiply across the top, negative 5 times 2 minus root x, and in the denominator, we take our first terms and square them. 2 squared is 4, always a minus. Take our last terms and square them. Root x squared, the root and the square cancel, leaving just the base x. And so this would be your solution. One of the things that you need to pay attention to, and this is going to be true for your Chapter 1-2 test, which will be a multiple choice test. Okay, but every question has the option of none of the above. Okay? And there will be some that are none of the above. Okay, but here's the other trick to this. Right? And because it's multiple choice, I made it more difficult just because the answers will be one of the choices potentially. Okay? If this particular form of your answer is not one of the options on a multiple choice, that doesn't mean that it's not going to be one of the other ones. You need to be able to recognize alternate forms of expressions. And so in this particular case, what I will generally do as far as the orders that I write answers is I will write all factors in standard form. Okay, so what that means is this 4 minus x is not written in standard form. Standard form puts the variables first from highest power to lowest power. Okay, and so in order to do that, what this problem would wind up looking like is the numerator would stay fine. Okay, if you have a radical, the standard form is only going to be for polynomials, so only the radicals aren't going to be affected. But what I would do is I would reorder these terms. Okay, I'd put the x's first, followed by the constant. Okay, and not only that, but I'll also write all my factors with a positive leading coefficient. Okay, so what that means is I don't want a negative in front of the x. So in order for me to get rid of the negative in front of the x, I have to factor out that negative. So again, the numerator wouldn't change. But what would happen, and you can go straight from this step to this step, and that is, as you reorder the terms and you realize your first term's negative, you have to remove that common factor. And so if I take a negative out of the 4, what does it become? Negative 4, right? If I take a negative out of the negative x, it becomes positive x. Okay, and so this is more likely what I would have. And then now, to continue to simplify it, what do you notice about these negatives? They cancel. And so your answer for this, as far as recognizing a multiple choice test, would most likely be this form. Okay? So be aware of that possibility when you're working through problems, especially on multiple choice type questions. All right, I want you to try one final example, please. All right, see if you can simplify this expression, please. 3 divided by root x minus 3 root 2. All right, so when you look to rationalize this, again, can you simplify your radicals at all? No, no need to. So we rationalize. We multiply by the conjugate. Conjugate is same term, so root x and 3 root 2. Root x and 3 root 2. Opposite sign between. We use a plus. And so when we simplify this, we multiply across the top. We get 3 times root x plus 3 root 2. Again, there's no reason to distribute that through. Just leave it as it is. Leave it as factors. And then across the bottom, we take root x squared, which is x, minus 3 root 2 squared. Now, when you square 3 root 2, you need to think of it in one of two ways. Right? If you take 3 root 2 and you square it, this square either applies to both factors of this product. The 3 squared is 9, root 2 squared is 2, therefore the whole thing is 18. So we get, in this case, a minus, always the minus in this sum and difference, 18. The other possible way that you could do this is you could take the 3 root 2, and before you square it, you could move that 3 back inside the radical. Well, what do you take the square root of to get 3? 9, right? So if you put that back into our radical as a 9, okay, and 2 times 9 is root 18, what's going to happen here between the radical, the square root, and the power 2? They cancel, leaving just that base of 18. So whichever way you choose to do that is fine, but that becomes your simplified form. And now, the question that often comes up with students, especially like at this time, but it continues until even through calculus, is students make the mistake of canceling factors incorrectly. And so if you look at this and you think that this factor of 3 can cancel with this term of 18, you're making a mistake. And the thing that you have to be aware of, when you cancel factors, you can only cancel factors that are identical to each other. So in this case, x minus 18 is a binomial factor. Right? There's no common factors you can remove for that. It's binomial, meaning it has 2 terms. So it could only cancel with another binomial factor of x minus 18. Okay, so just because 18 is a term of that factor doesn't mean it can cancel with this factor here. The only way that this 3 could cancel with a factor is if there were another monomial factor. So a factor with a single term. So if for some reason there had been a factor out here where you could multiply by, let's say, a 6 or a 9, then you would cancel that monomial factor, but it's not going to cancel. You can't cancel a monomial factor with a term from a binomial factor. Again, be really careful with that. We'll get into factoring stuff again in the next chapter, and we'll go through that in a little more detail, but be careful here. All right. So this is all the material from 2.1.